I want to remind you that we have the slope-intercept form, which is in the form y equals mx plus b. And remember, in this form, we have our slope as m, and we have our y-intercept as b. And remember, our intercepts are the points where our line is going to cross either the y-axis or the x-axis. So when we're talking about the y-intercept, the line is going to cross the y-axis at that point. So we're going to take a look at equations in the form y equals mx plus b today, but we're also going to see equations in the form ax plus by equals c. And remember that this is standard form of an equation. So remember, the number in front of x is our x-intercept. Well, it's not quite that easy, but we find our x-intercept that way and our y-intercept here. Now remember, we can't just use those numbers. We have to actually find, we have to plug in 0 for either x or y and solve for the opposite to determine that x or y intercept. So keep that in mind. So I'm actually going to erase this because I don't want to confuse you. That's not how you find the intercepts, but this is standard form. So I'm just going to write that here for you. Standard form, and we're going to see equations in standard form today. And my favorite way of understanding the y-intercept and the slope is to put the equation into slope-intercept form. So that's what you're going to see me do today. So let's take a look at exercise number 1, or the exploratory challenge number 1. And it asks us to sketch the graphs of the linear system on a coordinate plane. So we have two linear equations, 2y plus x equals 12 and y equals 5 6x minus 2. So the first thing that I'm going to do is graph that second equation because it is already in slope-intercept form. I already know where my graph is going to cross the y-axis, and I already know how many units up and to the right or left I need to move to get to my next point. So we see here that this second equation is in slope-intercept form. It is y equals 5 6x minus 2. So we already know that our y-intercept in this equation is 2, negative 2. And so that is the point where our graph is going to cross the y-axis. So I'm literally going to come over here to my graph, and I'm going to plot a point at y equals negative 2, because I know that my graph is going to cross the y-axis at that point. And from that point, I'm going to use my slope now to determine how many units up and to the right, because this is a positive slope, I need to move to get to my next point. So remember, we have rise over run, meaning we're going to go up first and then we're going to go to the right or left. So our slope is telling us that from this point, negative 2, we need to move up 5 units on the y-axis before we move 6 units to the right on the x-axis. So we're going to move up 1, 2, 3, 4, 5 units, and that brings us to positive 3. And we're going to move to the right 6 units. So 1, 2, 3, 4, 5, 6. So I have a new point right here on my graph. Now, this graph is pretty small, so I can't move, I don't think, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Actually, I can. My next point is right here, right at the very top of my graph. Now, what I'm interested in determining is where these two lines of this graph are going to cross each other at the same point, and that point is going to be the solution to my equation. So I have another equation here, and I'm actually just going to connect these points. So we're going to connect these points, and you know how I am about drawing a straight line. I can't do it. So I apologize for my poor line, but I will do my best. Okay, not quite straight, but good enough. We can see that the points are connecting. All right, in purple now, I'm going to transform this other equation, this 2y plus x equals 12, into slope-intercept form so that I know where my graph is crossing my y-axis, and I know how far up and over I need to move, or down and over I need to move in terms of my slope. So since I want y on the left side of my equation, for now I'm going to leave that 2y alone. And since x is being added to this side, I'm going to subtract x from both sides of my equation. And so I'm going to rewrite this now to show what this is saying. So we now have an equation that says 2y equals negative x plus 12. Now I want that y all by itself. So I'm going to divide both sides of my equation by 2 to get that y by itself. And so now I have y equals negative 1/2 x plus 6 because I divided both of my variable and my number on the right side of my equation by 2. So now on the y-axis, I'm going to plot my point at y equals 6 because my intercept, my y-intercept for this equation is positive 6. And now my slope is negative 1/2. So that's telling me I need to move down 1 unit and to the right 2 units. So I'm at 5 right now, well, I'm at 6. I'm moving down 1 unit to 5, and I'm going to move over to the right 2 units. So here's my next point. And I'm going to keep going from that point, down 1 unit to the right 2 units. Down 1 unit to the right 2 units. Okay, now I have a point that's at the same point as my previous line was at. So that's where my lines are going to cross. So I'm going to keep going so I can connect all of these. So down 1 unit over 2 units, down 1 over 2, down 1 over 2. And I'm actually going to go up 1 and over 2 so that I have 1 here as well. So now I can connect all of these points to each other, and there is the line of my second equation. And so for part A, it tells me, or it asks me, name the ordered pair where the graphs of the two linear equations intersect. So that means where are these lines going to cross? At the point that they're going to cross is the solution to our equation, and that is this point right here. So the solution to both of these equations is 6, 3. So I've got 6, and then I've got 3. So that is that point that is the solution to this equation. Now, we're going to be sure that this is the solution to the equation by verifying that indeed it is. So in our next slide, I'm going to move on to the next slide. For part B, it asks us to verify that the ordered pair named in part A is a solution to 2y plus x equals 12, which was our first equation. And remember, our coordinate pair that we said was the solution was 6, positive 3. So that means that 6 is our x value and 3 is our y value. So I'm going to plug those values into my equation so that I can be sure that both sides of my equation are equal, and therefore 6, 3 is a solution to my equation. So since my y value is 3, my equation is going to look like 2 times 3 because I'm plugging 3 in for y, plus 6 because I'm plugging 6 in for x, equals 12. So now when I carry this out, 2 times 3 is 6. So now I have 6 plus 6 equals 12. And 6 plus 6 is 12. So 12 equals 12. We can say that 6, 3 is indeed a solution to our equation. Now, they're going to ask us in part C to verify that the ordered pair named in part A is also a solution to our equation. So we're going to do the same thing. So for y, we're going to plug in 3. So we have 3 equals 5 over 6 multiplied by 6 minus 2. So now we're going to multiply straight across with our fraction. So remember, this is technically 6 over 1. So I have 3 equals 30 over 6 minus 2. So now I have 3 equals 30 divided by 6 is 5. 5 minus 2. And 5 minus 2 is 3. So I have an equation that is indeed 3 equals 3. So 6, 3 is also the solution to my linear equation, y equals 5, 6, x minus 2. All right, in this part D, they're asking us, could the point 4, 4 be a solution to the system of linear equations? That is, would 4, 4 make both equations true, why or why not? So we're very simply going to plug in 4, 4 for x and y in both of these equations to see if they are true using this coordinate pair, this coordinate point. So our first equation was 2y, so we're going to multiply 2 times 4 plus x, which was 4, equals 12. So now we have 8, because 2 times 4 is 8, plus 4 equals 12. And 8 plus 4 is 12, so 12 equals 12. So that could be a solution to that equation, but we need to be sure that it's also a solution to the other equation. So I'm going to plug 4 in for y. So 4 equals 5 over 6 times 4 minus 2. So now I have 4 equals 20 over 6 minus 2. So right away, I can't reduce 20 over 6 to a perfect number like I could 30 over 6. So I can only reduce 20 over 6 to a fraction, which is 10 thirds. And so now I have 4 equals 10 thirds minus 2 over 1. So now I have to multiply the top and bottom of 2 by 3. So I have 4 equals 10 thirds minus 6 over 3. So we can already see that this is going to be 4 equals 4 thirds, and 4 will never equal 4 thirds. So that means that 4 does not make both equations true, and it is not a solution to this system of linear equations. So we're going to say no, not a solution to this system. And in your homework, I'm perfectly content with all of this work being your explanation, being your why or why not. So you don't have to explain why or why not. I'd just like to see your work. So we will probably not go through all of these problems because they are all going through the same things. And I want to make sure that we have time for our science lesson. But I do still have a bit of time before I am comfortable moving on to our science lesson. So let's keep going. Let's do another problem. It will be really great for us to keep doing these so that you guys fully understand how we're doing this. So let's look at number 2. It says sketch the graphs of the linear system on a coordinate plane. So we have x plus y equals -2 and y equals 4x plus 3. So I like this equation best because it's already in slope-intercept form, and I know where my line is crossing my y-axis. So my line is going to cross my y-axis at +3. So I'm going to come over to my graph, and I'm going to plot a point at +3 because that's my y-intercept. Okay? Now I'm going to use my slope to determine how many units up and to the right, because this is a positive slope, my next point on my graph will be. So since my slope is 4, I know that that slope is technically 4 over 1. So that means I'm going to move up 4 units and to the right 1 unit. So I'm going to move from this point 3 up 4 units on my y-axis. So 1, 2, 3, 4. So I come to +7, and I move to the right 1 unit. So there's the next point on my graph. Now, since I can't move up 4 units on this graph anymore, I'm going to move down 4 units. So even though this is positive, I can still move down and to the left to fill in the rest of my line. So I'm going to move down 4 units, 1, 2, 3, 4, and over to the left 1 unit. So there's one more point. And since I can't move down anymore, I am just simply going to connect these points, and this will be the line of my equation. So there's my line for me. That's a really terrible line. It should not slant like that. That's all right though. We're just looking for the point where these two lines are going to cross. So remember, I'm not a huge fan of standard form. It doesn't help me a lot. So x plus y equals -2 is my next equation. And I want to put this in slope-intercept form. So I'm going to subtract x from both sides of my equation because I want y all by itself. So now my equation reads y equals -x minus 2. And that gives me my y-intercept, which is -2. So that's where my graph is going to cross the y-axis. And it also gives me my slope, which is -1. And that's going to tell me how many units down this time and to the right I need to move, because that's technically -1 over 1. Keep that in mind. All right, so I'm going to plot a point at -2 on my graph. And I'm going to go down 1 unit and to the right 1 unit. And that's as far down as I can go. So I'm going to go up to 1 unit from my -2, and I'm going to go to the left 1 unit. And so here's my other point. So from there, up 1 unit, to the left 1 unit, up, left, up, left, up, and left again. So there is my line, and I can already see exactly where my 2 lines are crossing. They are crossing at -2, -1. So when they ask me, no, I'm sorry, they're crossing at -1, -1. So when they ask me in my next problem, the solution to my equation, my solution is going to be -1, -1, because that's the point where both of those lines are crossing on my graph. So I'm going to flip now to that question, and it says, name the ordered pair where the graphs of the 2 linear equations intersect. So that is going to be my point, -1, -1. And now they're going to ask me to verify that that point is indeed the solution to both of these equations. So I'm going to plug those numbers in for x and y and solve. So for this first equation, it's x plus y equals -2. So I have -1 plus -1 equals -2. And when we have 2 negative numbers and we're adding them together, we get a bigger negative number. So indeed, -2 equals -2. So -1, -1 is a solution to that equation. But remember, we're looking at systems of linear equations. So we also want -1, -1 to be the solution to the other linear equation in our system, which is y equals 4x plus 3. So down here, I'm going to plug -1 in for y, and I'm going to plug -1 in for x, and I'm going to solve this problem to make sure that both sides of my equation are equal. So now I have -1 equals -4 plus 3. And what I know is that -4 plus 3 is -1. So -1 equals -1. And that is indeed, -1, -1 is a solution to the equation y equals 4x plus 3. So we can confidently say that -1, -1 is a solution to our linear system. So now in this last part, they give us a new coordinate point and they ask us if it can be a solution to the system of linear equations. So we're going to plug in -4, 2 into both of our equations and see if -4, 2 can be a solution to both equations or a solution to our system. So we're going to use x plus y equals -2 first. So we've got -4 plus 2 equals -2. And -4 plus 2 does equal -2. So -2 does equal -2. So that's a true statement. And now we also need to see, does -4, 2 make y equals 4x plus 3 a true statement? So now we have 2 equals 4 times -4 plus 3. And now we can already see the problem with this statement, because now we have 2 equals -16 plus 3. And -16 plus 3 will never equal 2. In fact, it equals -13. So now we have 2 equals -13, which will never be a true statement. So this point, -4, 2, is not a solution to our linear equation system. So no, not a solution. And your work is perfectly acceptable for the y. So no, it's not a solution to our system. So we're going to go through at least one more of these problems, just so I'm sure that you guys understand it, and then we'll probably move on to our science lesson. But before we move on to our science lesson, I'll make sure nobody has any questions. So I'm going to look at one more problem, and it asks us to firstly sketch the graph of the linear system on a coordinate plane. So now we have 2 equations, and they are in standard form instead of slope-intercept form. So I really want these to be in slope-intercept form, so I'm going to transform them. So I'm going to start with my first equation, since they're both not in slope-intercept form. So 3x plus y equals -3. So remember, I want y all by itself, so I'm simply going to subtract 3x from both sides of my equation to get y all by itself. So now my equation in slope-intercept form is y equals -3x minus 3. So I know 2 things. One, my graph is going to cross my y-axis at -3. So I'm going to go ahead and plot my point at -3 on my y-axis. And now I also understand that my slope is -3 over 1, meaning from each point, I'm going to move down 3 units and to the right 1 unit. So we're going to move from this point -3 down 3 units. So we're at -6, and I'm going to move to the right 1 unit. So here's another point on my line. Now, what's really neat about a slope that's -3 over 1 or -3/4 or negative whatever is that you can either make the top of the fraction your negative number or the bottom. So this allows me to also move up 3 units and to the left 1 unit. So from my point -3, I'm going to move up 1 unit and to the left 1 unit. I'm sorry, up 3 units and to the left 1 unit. I'm going to do the same thing from that point right there. So up 3 units, 1, 2, 3, and to the right 1 unit. I'm going to do it one more time. 1, 2, 3, to the left 1 unit. I think I said right, I meant left. Sorry, guys. All right, so now I'm going to connect these points so that I have a nice line representing my equation. So there's my nice line representing my equation. And now I need to transform that other equation into slope-intercept form because I want to know where these two equations are going to cross. I want to know the solution to this linear equation system. So I have -2x plus y equals 2. And since I want y all by itself, I'm going to add 2x to both sides because right now it's negative or being subtracted. So I'm adding 2x to both sides. And now my equation in slope-intercept form is y equals 2x plus 2. All right, so the first thing that I know about this equation is that my y-intercept is positive 2, meaning my line is going to cross my y-axis at positive 2. So I'm simply going to plot a point at positive 2. Now my slope is 2 over 1, meaning I'm going to move up 2 units and to the right 1 unit to get to my next point. So from that point positive 2, I'm going to move up 2 units, 1, 2, and to the right 1 unit. I'm going to do one more time over here. So up 2 units and to the right 1 unit. And now because I want to fill in my line, I'm going to move down and to the left. So I'm going to move down 2 units and to the left 1 unit. So here's my new point, crossing the other line. Down 2 units to the left 1 unit. And I'm going to keep doing it until I'm at the end of my graph so that I have a really nice line or really nice points to connect my line. Crossing right there. All right. So when they ask me in my next slide where these two lines cross or intersect or what the solution to my linear system is, I can say that it is -1, 0 because that's where the two lines are crossing. They're crossing at -1 on the x-axis and 0 on the y-axis. So let's actually move on to that question. And it says, name the ordered pair where the graphs of the two linear equations intersect. So we already said that that would be -1, 0. And now we need to verify that that ordered pair is indeed a solution to both of these linear equations because we want it to be a solution to our system, and therefore it has to be a solution to both linear equations. So let's take a look at B, and let's plug in -1, 0 into this equation. So we have 3 times -1 plus 0 equals -3. So now we have 3 times -1 is -3. So we've got -3 plus 0 equals -3. Whoops. So we have -3 equals -3. So that is indeed a solution to that linear equation. We're going to do the same thing for our next linear equation, which is -2x plus y equals 2. So we're going to plug in -1 for x. So we've got -2 times -1 plus 0 equals positive 2. So what we know is that a negative times a negative is a positive. So now we have 2 plus 0 equals 2. And ultimately we have 2 equals 2, meaning that -1, 0 is a solution to this linear equation as well. So now we can say that -1, 0 is a solution to our linear system. Now in the last part, just like in the last two problems, They're asking us if the point 1, 4 could be a solution to the system of linear equations. So they're asking us to plug 1, 4 in to both of these equations to see if it could be a solution to the system. Will it make both sides of the equation true? So let's start with 3x plus y equals negative 3. So I've got 3 times 1 plus negative 4 equals negative 3. And so I actually have, did I do that incorrectly? Nope. Yes, I did. It's not supposed to be negative 4. Sorry about that, guys. So I'm going to take that away. So plus 4. So now I have 3 plus 4 equals negative 3. And never in a million years will 3 plus 4 equal a negative number because it equals 7. And 7 will never equal negative 3. So right away, we don't even have to do the math for the next equation. We can just simply say, no, this is not a solution to this linear system because it's not true for one of the linear equations. So no, not a solution. And our work is enough to prove that. We don't even have to do it for the other equation to determine if it's true because it's not true for one of them. And if it's not true for one of them, then it's not true for the whole system. So that is what you guys are going to be doing in your exit ticket in your problem set. In fact, you're going to be doing this exactly. So I'm not actually going to go through the next two problems because I think that that was enough for you guys to fully understand. So what I'm going to do is I'm going to stop this